Hi, it's a supplementary math lesson for Algebra 1, lesson 87, multiplying radicals. And again, don't let that term throw you, radicals. When you hear that term in math, you just remember it has that square root symbol involved in the problem, radical problems, okay? So this goes way back to lesson 66. So it's been a while since we touched on this subject. You might want to go back in your textbook to lesson 66 and reread that section to get familiar. And simply put, what they were saying is if we have a multiplication in that lesson 66 of two radicals, two square roots, we can combine the multiplication of the numbers under one square root symbol, okay? And vice versa. If we have two numbers that are multiplied under a square root symbol, we can split them out into two square roots multiplied by each other, okay? And we have been typically doing this when taking the square roots of larger numbers, okay? We have been taking advantage of this second expression of it's the same rule, it's just a different expression, okay? And so when we say, can we take the square root of 200? And remember, what does that mean, the square root? What number multiplied by itself, okay, will give me 200? And unless you memorize your squares up to whatever, that might not be readily apparent to you. You know, we can recognize, 2 times 2 is 4, 8 times 8 is 64, 10 times 10 is 100. Once we get above 100, unless you've memorized beyond that, it's kind of hard to recognize, well, can we actually take a square root of that number? So what we did is we said, well, what we do is we factor it. Okay, if we factor 200 and we start with the smallest factor, we divide it into 2 times 100. Well, we recognize 100 we can take the square root of because it can be split apart into 10 times 10. What number times itself, 10, will equal 100. So in effect, what do? When we do that? We split that square root into a 2 times 100. Okay, then we take advantage of our multiplication rule for radicals, for square roots, and we split that apart into the square root of 2 times the square root of 100. And we recognize we can take the square root of 100. It's 10. 10 times 10 is 100. So we would take that square root and we leave the square root of 2 because we cannot take the square root of 2. There's not an integer, okay, that multiplied by itself will get us 2. Now, it's typical. You would move the integer, the number, to the front end. We put the radicals to the rear end of our expression, okay? That's why I moved that. If it would be square root of 2 times 10, we would typically express it as 10 square root of 2, okay? So we're going to use these rules and to do multiplying radicals now, and I'm going to be going down the examples on page 313 of your textbooks. If you want to turn there, go ahead and pause the video and get that set while I write this first problem down. Okay, so this is example 87.1. We are multiplying 4 square root of 3 times 3 square root of 2. And we recognize when we multiply numbers together, it doesn't matter what order we do that in. Okay, so we can think of it as 4 times the square root of 3 times 3 times the square root of 2. Okay, we're going to take advantage of that. It doesn't matter what order we multiply the numbers by. We're going to multiply the integers times each other. Okay, 4 times 3 is 12. Then we'll multiply the square roots times each other. Okay, the square root of 2 times the square root of 3. And what we're going to do, we're going to take advantage of this rule up here. When we have two square roots multiplied by each other, it's simply the square root of the numbers multiplied by each other under the symbol. 2 times 3 would be 6. So there we have simplified, we have multiplied that problem together. The only thing we need to keep aware of is this square root the simplest we can get. Can we split it apart into a smaller square root times an integer? With 6 we can't. Okay, the factors are 1 and 6, 2 and 3. Can't take the square root of that. Okay, going on to the next example. 87.2. 4 square root of 3 times 6 square root of 6. Let's multiply the integers together just like we did. I'm not going to break them apart now like I did the last time. I just know I can multiply them in any order. 4 times 6 is 24. I get a square root of 3 times 6 is 18. Okay? Can I reduce that square root symbol? Is that the simplest expression of the square root? I don't know. Let's see. If I factor that, it's 2 times 9. Whoop, I recognize I can take the square root of 9. It is 3. Okay? So in other words, that's the same as 24 times the square root of 2 times 9. Okay? I can take the square root of 9. It's 3. So I'm going to take that out here and move the 3 to the outside. Now everything is multiplied together here. Okay? So 24, that 3 is multiplied by 24, and those numbers are multiplied by what is left under the radical symbol. The only thing left here is the 2. Okay? So all we have to do is multiply these together. Okay? 24 times 3 is 72. Square root of 2. Okay? That is our simplest form of the expression. Now this would have been a correct answer. It's numerically, I should say, excuse me, equivalent to this, but it's just not simplified down to the smallest square root that we can. Okay, let's go on to the next example. 87.3 at the bottom of page 313. Okay, so here we have a number multiplied by a radical, and then that's multiplied by an expression that is a sum. Okay? In other words, we have the same thing as if we said A times B plus C. Okay, this is our A term, this is our B term, this is our C term. And how would we tackle that? We would tackle it by multiplying it out by the distributive method. We would multiply A times B and A times C. We're going to do the same thing here. We multiply it here. 4 times 5 is 20. The square is still on the same two terms. I just multiplied the numbers first. Now I go back and multiply the radicals. The square root of 3 times the square root of 2 is the square root of 6. Okay, I've done that multiplication. Let's do the next step. 4 times 6 is 24, a positive 24. 3, square root of 3 times the square root of 3 is the square root of 9. Oh, I recognize I can take the square root of 9. Okay, it's 3. This becomes 24 times 3, which we said in our last example was 72. I can't really simplify this one over here. That is as simple as it can get. The square root of 6 is the smallest radical I can express. Okay, can't really simplify that. I could simplify this one. So this becomes my answer. 20 square root of 6 plus 72. Okay, let's go on to the next example. 87.4 at the top of page 314. I'm going to use that, leave that distributive symbol up there because it's the same type of problem. 4 square root of 2, and we're multiplying it by an addition, a sum of 3 square root of 2 plus 5. Okay? It's the same drill. I'm going to use the distributive method. Multiply this first. 4 times 3 is 12. Let's go back and do the square roots. Square root of 2 times square root of 2 is the square root of 4. Okay? Then let's multiply the next term. 4, well, there is no square, it's just 5, is 20, plus 20. And we notice there is no square root term attached to the 5. Okay, so it's just the square root of 2 times nothing over there. There's no square root term. So that square root of 2 remains by itself. Okay, so then we look at that. Well, we recognize we can take the square root of 4. It's 2. We can't really simplify this expression over here, but we can multiply these together to get 24 plus 20 square root of 2. Okay, and that is our answer for that example problem. Okay, so it's same algebra using the distributive property. We're just using our rules to combine radicals under one radical symbol, and then we're also using the same rule expressed in reverse. If that radical symbol can be reduced, like this one, if it's a bigger number that can be reduced to a simpler form, then we kind of split it apart. So we combine them under one radical, and then maybe at the end we split them apart to get one answer. Okay, so let's see if we can do. I don't see one that they have involving multiplication with subtraction right now. So, okay, good. I'm sure we'll get into that following on. So, I hope that helps. Again, refresh with lesson 66 if you need to. Shoot an email or a text message with any questions. So long for now.